Before we begin, pause for a moment. Let your shoulders drop, unclench your jaw. Grab a coffee, tea, or whatever helps you slow your thoughts just enough to listen. Because this story isn't about a far-off galaxy. It's not about ancient history. It's about a place you could visit. A place where time moves faster. Not metaphorically, not psychologically, physically. And before we go any further, if you enjoy calm, curiosity-driven videos that mix science, scale, and quietly unsettling ideas, take a second to like this video, share it with someone who enjoys thinking too deeply, and leave a comment at the end with your thoughts. Now, here's a question you think you already know the answer to. How fast is time passing right now? Your instinctive answer is 1 second per second. That feels obvious, trivial even. But it's wrong. Time does not pass at the same speed everywhere. And once you really understand that, the world starts to feel very different. Let's begin with something simple. Imagine two identical clocks, perfectly synchronized. You keep one with you. You place the other somewhere else. If you wait long enough and bring them back together, you might expect them to still agree. But under the right conditions, they won't. One of them will be ahead, the other behind. Time itself will have disagreed with you. This isn't speculation. It's not a thought experiment. It's been measured repeatedly. And the difference depends on two things: speed and gravity. Let's start with gravity. According to Einstein's theory of general relativity, gravity is not just a force, it's the curvature of space-time. Mass bends space-time, and time flows differently depending on how deep you are in that curve. The stronger the gravity, the slower time passes, which means time moves faster where gravity is weaker, and gravity is weaker the farther you are from mass, including Earth. This leads to a strange conclusion. Time passes faster the higher you go. At sea level, time ticks a little slower. On a mountain, it ticks a little faster. In orbit, faster still. On a GPS satellite, significantly faster. In fact, GPS satellites have to constantly correct for this effect. If they didn't, your phone's location would drift by kilometers every day. Your navigation depends on time dilation. Now pause and really absorb that. Your phone works because time moves at different speeds in different places. Time is not universal, it's local. Which brings us to the place where time on Earth runs the fastest. Mount Everest? Close, but not quite. The key isn't just height, it's distance from Earth's center of mass. And Earth isn't a perfect sphere. It bulges at the equator, which means something strange happens. The surface at the equator is farther from Earth's center than the surface at the poles, even though the poles are technically closer to sea level. So where is gravity weakest? Where does time pass fastest? At the equator. Specifically near the top of a mountain on the equator. And the best candidate we have is Mount Chimborazo in Ecuador. Chimborazo is not the tallest mountain above sea level, but measured from Earth's center, its summit is the farthest point from the planet's core, which means if you stand on the peak of Chimborazo, time is passing faster for you than anyone at sea level. Not by seconds, not by minutes, but by microseconds. Tiny, but real and measurable. Now you might be thinking, so what? That's negligible. But that reaction misses the point. Because if time can differ by microseconds, it can differ by more, a lot more. Near a black hole, time nearly stops, relative to distant observers. In extreme cases, one person could age years while another ages seconds. Time is not a river flowing uniformly, it's a landscape, warped, uneven, and you're always standing on a slope. Now let's bring this closer to home. You are aging faster than someone sitting on the floor below you, right now. The difference is absurdly small, but it exists. And here's where things get unsettling. Your head is aging faster than your feet because your head is slightly farther from Earth's center, which means you're not a single age, you're a gradient, a vertical slice of different times. Now let's add speed. Special relativity tells us that the faster you move, the slower time passes for you. This has also been measured. Atomic clocks flown on airplanes return slightly behind clocks left on the ground. Astronauts age slower than people on Earth. Again, tiny differences, but cumulative. Now imagine combining both effects, high speed, low gravity. That's space, which means astronauts who spend long periods in orbit return slightly younger than they would have been otherwise. Time travel? Yes, forward, into the future. Everyone is already doing it, just at different rates. Which leads to a strange philosophical problem. If time passes at different speeds, what does now even mean? Is there a universal present? According to physics, no. There is no single moment that everyone shares. Now depends on where you are and how you're moving. This is not intuitive. Your brain evolved in a world where these differences are tiny, so it ignores them, but the universe doesn't. Now let's take this one step further. Imagine two people. One lives their entire life at sea level. The other lives their entire life at the summit of Chimborazo. Over a lifetime, the difference in experienced time adds up. Still small, but measurable. One person will have lived slightly more time than the other, not metaphorically, literally. Which means aging is not just biological, it's gravitational. Now ask yourself this: if time can move faster or slower, can it ever stop? According to theory, yes, at an event horizon. From the outside, time at the edge of a black hole appears frozen, which raises a deeply unsettling idea. Time is not fundamental, it's emergent, a property of space-time geometry, which means the universe does not have one clock, it has infinitely many, all disagreeing slightly. Now let's return to Earth one last time. There are experiments where atomic clocks are separated by just a few centimeters in height. They drift apart, measurably. Time difference detected over days, not years. This means time dilation is not a distant cosmic curiosity. It's happening everywhere, all the time. We just don't feel it, because your brain stitches moments together, creates continuity. But physics doesn't care about continuity. It tracks intervals. Now here's the unsettling question. If time moves at different speeds, what determines causality? What determines order? Physics answers this with light cones and space-time structure, but intuitively it feels wrong. We want a single timeline, a shared present, but the universe doesn't give us one. Instead, it gives us overlapping local times, each valid, each incomplete. So where does that leave you? Standing somewhere on Earth, at a specific altitude, moving at a specific speed, experiencing a unique rate of time. No one else shares exactly your temporal perspective, which makes this moment uniquely yours. Not just emotionally, physically. And here's the final twist. Because time moves faster at higher altitudes, the future arrives slightly sooner at the top of a mountain, which means if you want to reach the future as quickly as possible, you should go up, not forward. Now, of course, this won't let you skip years, but conceptually, the future is unevenly distributed, and some places reach it first. So, the next time you look at a mountain, or an airplane overhead, or a satellite moving across the sky, remember this: they are not just in different places, they're in different times, all moving forward, all slightly out of sync. And you're standing on a planet where time is constantly slipping, faster here, slower there, without ever stopping long enough for us to notice. If you enjoyed this video, make sure to like it, share it with someone who enjoys science and strange ideas, and leave a comment at the end with your thoughts. Where do you think time feels fastest? And if you could choose, would you want it to slow down or speed up? Because the most unsettling thing about time isn't that it passes,
It's that it never passes the same way twice.